Hey everyone, welcome back to my channel, and this is the next video wherein we are going to discuss a new question of the linked list. So it's a very famous question, it's an important question as well to understand the good concepts of linked list. So this question is asking you to delete the nth node, that to be from the last of the linked list. So given a problem statement, you can see that 1, 2, 3, 4, 5 are the nodes, and from the last, the second node has to be deleted, and at the same time you have to return the head of the final linked list that you will be having or left with. So there are three approaches that I've seen so far in order to solve this question. So those are pretty much like a little bit not going to be solving the question in a single go. That is that you will be just reversing the linked list, and then from the last you will be going to the second or third position, whichever has been asked you to delete, and from there once you will delete it, and then again you will be reversing the linked list at the end so as to give the answer. So that's not an efficient technique, and they are asking us to delete the node in such a way that if we can do that in a single pass. So that's what we're going to be looking in this particular video, and it's the efficient approach to solve this question. So what's basically the intuition behind this particular question is, because you have been asked to delete a node, so we have to reach to this particular location. Once we'll be able to reach to this particular location, we will be able to do the modification, we'll be able to make the changes, right? So that's what the thought process is saying. So what exactly is the way in order to reach to this particular location? One is that you can start with two different pointers, and for using those two pointers you can keep on maintaining the gap. So let me also be going to be showing you this particular approach that I'm talking about, that how you can do that. So now let me just remove this thing over here. So this is basically the example you can consider over here, that you have been asked. So this is basically my linked list is 1, 2, 3, 4, 5. Let me also remove this particular thing so that there is no confusion at start, and then we'll proceed step by step. So you can see that this is basically the linked list which has been given to us: 1, 2, 3, 4, 5, 6, 7, 8. Just an example over here, and this is a null pointer, right? So at the end it is pointing to the null. So now if I'll say that you have to remove the third node from the last, so what that node will be 8, 7, 6. This is the third node that we are reaching, 1, 2, 3, right? So this is the node that we have to delete, and we have to finally make the connection as 1, 2, 3, 4, 5, 7, 8. We have to remove the sixth node, right? So this is what the question is asking you to do. So that means you have to reach to this particular point, and if you will be able to connect the fifth directly to the seventh, then you will be having your answer in your hand, right? You can straight away connect the 5 to 7, and that's what gonna lead to the answer. So that's what the thought process is saying, that you have to just remove to this particular node. But at the same time, in order to make this kind of a change, you have to reach to this particular node, this number 5 over here. So how will you do that? The simple thought process is saying that you can use two different pointers, and also you will have to use an auxiliary node. I'll explain you what exactly that means is. So what you can do is that you can create an auxiliary node just to make a start over here, and from here you can have two different pointers. One is the slow and one is the fast pointer over here, right? So this is not exactly the slow and the fast pointer technique. I'm just naming this particular as a slow and fast, because fast is going to be something that is going to be moving ahead of the slow. So, but at the same time, that will not be exactly moving fast. So let me explain you what exactly this thing is. So I will be creating an auxiliary node that is 0, and I will be connecting 0 to 1 over here, right? So now my new linked list is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is my linked list is, and I will be having two different pointers, that is slow and fast. So I'll be starting from this slow pointer and also from this fast. Firstly, I will move this fast pointer by n spaces, right? So if I'll move this fast pointer by 3 spaces, then it's going to reach to this particular location, 1, 2, 3, right? So this gap will be maintained over here, as you can see that in slow and fast, by 3 spaces, because this is what the question is asking us to do. So we have to maintain the we have to remove the third place from the last. So that's the reason I kept or made fast pointer move by 3 spaces. Once that is moved, let me also make a figure over here. My fast is gonna reach to this particular point. So what I can do is that now I have maintained a space between these two pointers. I can start moving this ahead, and I'll keep on moving till the time my fast has reached to the last location. Once my fast has reached to the very last position, that is number 8, I will be able to move my slow pointer to this particular point. So what's going to happen, I'll start moving both of these pointers one by one spaces after maintaining a space that I needed, which is number 3. If this has been asked by number, let's say 4, then I will be having the space as my slow would be at this particular point, and so this would have been like this way, because the spaces which will be maintained in between these two pointers is going to be by 4 spaces, because now we were using the example of 3. So that's the reason we first of all move the fast pointer by 3 spaces, then we start moving both of them one by one, and till the time the fast has going to be reached to this particular point. So I will be at my position which I needed, right? So that's what we are doing over here, and let's try to see what next we have to do. So now that my slow pointer has reached to this particular point where I wanted to initially. So what I can do is that it's a very simple thing now we have to do. We just have to connect the slow dot next to slow dot next dot next. That is 5 to 7 straight away, and I'll get my answer. So that's what the simple process is. This is just a kind of an intuition that can be built, because there's kind of a logic is used in some other questions as well, that how you can do the modification from the last position. So for that thing, you can use 2 different pointers, and you can move one pointer by the amount up to which you need, and then you can maintain a space between them, and then you can start moving both of them one by one, so that you will hit the null, or you can say the last position of one pointer, and the slowest pointer is going to be giving you the answer that you needed, and that will be at the position where you actually want to do your modifications or calculations. So that's what the thought process is. It's a very simple approach, and let's write down the code over here. So code is also going to be pretty simple. It's not that complex. It's just the same thing that we have discussed. We're going to be doing the same thing. So very first thing is that I will be creating my, let's say, I'll call this as auxiliary node only. So there is a reason in order to create the auxiliary node as well, because the very simple thing is that, let me open up this thing once back. So the reason why we created auxiliary node, because we wanted to reach to the location one left, or you can say one space before, to the node that we actually want to do the modifications on, because we wanted to do the 3rd location. So that's the reason we want that to be at the one before location, right? That is the 5th node over here, right? So that's the reason we are using this with the 0 node over here. So let me write down the code. It's very simple. So now that I have my auxiliary node over here, so what I need to do, I will have to create 2 pointers. What is slow? And slow is going to be basically having something called as the location of auxiliary, because we're going to be starting from there only, and also my fast pointer, that is also going to be starting from the auxiliary location, that is the very first location. So what I need to do next is I also need to connect my auxiliary to, okay, so that will be auxiliary dot next, because we want to connect our head pointer, because we want to have our final linked list as connected with the auxiliary node. So that's the reason auxiliary dot next has to be connected with the head. Now what do we want to do? We want to shift our pointer by 3 locations. So I'll be starting a for loop, that is int I equals to 0, I less than my n, because I'll be moving by whatever the numbers of n is going to be, then I plus plus. And what I need to do over here is that I will be shifting my fast pointer by fast dot next. So now my fast pointer is going to be at the position nth from the starting. Okay, so this is going to be moved by the nth positions, And next is going to be like, I will be starting my slow pointer now. Both of them will be now maintaining a space of n in between them, so that the spaces will be maintained and we can proceed further to the last location. And the very fun thing that I have to make sure that the fast dot next, I need to reach to the last location, right? Not to the null location, because from there only I will be just will be able to reach to the third location over here, right? Because now you can see that from this particular picture, it is saying the n is equals to 2. So that means from the last, I have to be at the second location. So my slow pointer will be at this particular location and my fast pointer will be at this particular location. Then I will be able to do the modification. So for that thing, I will just keep on checking till the time my fast.next is not equals to null. Then only I have to get stop and I have to come out of this particular loop. Okay, so let's do this thing. Okay, slow equals slow dot next, and also my fast pointer is gonna move fast equals fast dot next. Pretty much simple, right? As of now, we have maintained the space over here, and now we have moved our slow pointer to the desired location, which is at this particular location, to the node before the one which we want to remove. And now my slow, I want to connect my slow dot next to simply slow dot next. So this is the only thing that I wanted to that I'm left with. So my desired node that I wanted to connect with has been connected. Slow will be this 3 will be connected to 5, and at the end, what I need to return is something called as return my auxiliary dot next. That is this particular location, the very initial head location that I had created at the very first go. So let me run this particular code. This is a very simple code, and let's try and execute this. So there is some, okay, so this is the error that I've got. Okay, so this should be working. Yes, it's working and it has been accepted. So let's try to submit this. It's definitely gonna work, as it seems hard to be like. Yeah, so that's a very simple concept. You just need to remember, or you can say just have to, build a logic that if you want to check something that to be from the last, then definitely you have to use 2 pointers in such a way so that they can maintain the space to the desired location, right? That you need. So that space will be maintained, and you can shift those 2 pointers one by one to the last location. And once you're at the last location, your pointer will be pointing to the location that you needed, right? So that's what the whole thought process for this particular question is. There is one other brute force, or you can say that approach is that you can just reverse the node, and from the last position you can go to the nth node, and then you can delete it, and then again once after making the modification, you can again reverse a linked list. So that's a different kind of a logic. So yeah, that's pretty much about this particular question is, and that's what the whole logic is. And if you like the video, if you think that it's a good one, and if you have any other approach as well, you can just put that in the comment box. If you have any question, we can also discuss that. So yeah, thanks for watching, guys. Thanks. That's it in this video. See you next time.